So here we are on page 30. Here we are on page 36 in your packet, and what we have is a situation where the researcher thinks that women have to pay more than men for a particular car model. Okay, so this is an interesting problem because even though we have two different people giving us data, you know, even though we have women giving us data and men giving us data, and those are different people in those in those subjects, the people are actually paired by what particular car. So there were technically going to be 8 values, 8 numbers, 8 pieces of data that we want. And I don't care what the cost of that car was for the woman or the cost of the car was for the man. I'm interested in what's the difference between what they paid. Okay, so therefore I have paired data. And so that's how we knew it was paired, because I'm just only interested in the difference between what they paid for that particular car. All right. So, and now notice they gave you all the information that, you know, they gave you the women information and the men, and then they gave you the difference. So they did that because they didn't want to give it away that it was a matched pair. They wanted you to have to think about it, and so they gave you all the data to where you could do this problem with 2 independent means. Okay, so you could do, so that way if you didn't really know what you're doing, you may have done it that way. Okay, so we are going to go with that. This is paired data, and this is nice. They do give us the dot plots, and so they give us the dot plots for both of them, interestingly enough, and then they give us the dot plots for the differences between them. Okay, and again, they're doing this because, you know, they don't want to lead you to which test to choose. They've given you all the stuff that you could do if you were doing 2 means or paired. So do the data provide convincing evidence that on average, women pay more than men? So here's how that looks. We're going to be doing our matched pairs, okay? And so then what we have is so this is where we're just having one mean. And so we have the mean, and I'm going to define the way I subtract, and that's women minus men. And so this is the average difference that the women in the amount paid between men and women for the same model car. So they were paired by car. Go ahead.
Could you say the average difference in purchasing prices for men and women?
Yes, you might. I'm wondering if you need to include this for the same model car. So let's actually go on over to the grading guidelines and see exactly what they wanted. So we get that. So so see, look, they say here, the difference in the purchase price, the average difference in the purchase price, which I think you said, for the women and the men, they say for identically equipped cars of the same model. Let's see if they ended up taking off for that if you didn't do that. So I don't know. It just says that you get a credit for doing the correct parameter and the correct hypothesis statements. That gets you a point. I don't see any notes on here. Let me see. Okay, I don't see notes specifically saying that you have to say the identically equipped cars. Okay. All right, so that's a detail that I wouldn't know until I went actually to the session and actually graded this. So I'd be careful, because this, you know what, you really are identifying the way they're paired. So I think you really do want to indicate how they're paired. Okay. So our null hypothesis, of course, that there is on average, no difference in what they pay, and then we think women are paying more than men. See, that's why it matters that I'm defining the way I'm subtracting. So W minus M is greater than 0. If you had done M minus W, then it would be less than 0. All right, so here's our conditions. Randomly selected men and women matched for the same model car is stated. Independent, 8 is less than 10% of all such cars bought by paired men and women. And then here's that additional thing. Each pair of cars is independent of the other. So each set of purchase prices for each car is independent of the other set of purchase prices for the cars, okay? So that's where that independence comes in. It was not large enough, okay? But I can see from the dot plot, and I defined which dot plot I use, okay? Especially since they gave us all of them. See, they gave us it. So tell me, which dot plot are you talking about, okay? I'm talking about this one, the dot plot for the differences, okay? So you see how very exact and detailed I am and specific to make sure that there is no question as to what I'm talking about. Okay, so the dot plot for the differences between the women and men, the results are somewhat symmetric, unimodal, and have no outliers, so the approximately normal model applies. Okay, let's come over here and look and see exactly what they said. Their ideal solution then, step that you got the second point, if you named the thing and, oh, here's the one about the assumptions, okay? Yeah, step 2 is you named the correct thing and you checked the appropriate conditions or assumptions. So we'll say in a minute, we haven't done that yet, that it's a one mean t-test for paired data or for matched pairs. Either way, that would be the name. In fact, that's the next step. Okay, and then here we say, the sample is randomly selected from the population, and the population price of the differences, see how they specifically say which dot plot they are referencing, okay, is normally distributed or the sample size is large. Okay, so let's see what they have here in this little thing here they're saying. It's not large, so we need to investigate whether it is reasonable to assume that the population of the price differences is normally distributed. Okay, see, here we go. Look at this right here. The dot plot of sample price differences reveals a fairly symmetric distribution. So we will consider the second condition met. See how they're pretty much not ever going to not continue. Okay, so there you go. That's how they described that. Okay. So there's our PHA and our N, which is matched pairs t-test, or one mean t-test for matched pairs, whichever. Okay, now, calculator-wise, just kind of talk about that real quick. I would have put that into my calculator. Since I know all I need is the differences, I probably would have just put those differences in list 1. If I was like actually taking this test, I probably would have just gone to stat edit, and I was doing some other stuff yesterday, and I would have just gone to list 1, and I would have put just that one list of differences, okay, those 8 numbers. And so then I would go and stat over to test. Oh, you know what? In fact, look at the way they gave us information. They gave us this as well. So either you can put this data in list 1, okay, or you can do the stats, the tab. So here, when we are on our calculator, we're doing the t-test, we can either be using the data tab or the stats tab, okay? So you had the option of how to do that. Now, the null hypothesis would be the 0 difference, and then we were thinking that it was greater than 0, so that's how our calculator would have looked. All right, so when we do that, then we include the test statistic, the p-value, and the degrees of freedom. Who's got a mean test? T, not Z. Must include the DF, okay? So there's your, and this was N minus 1. So that's why it was 8. So since my p-value is low, I'm going to reject HO, and I have evidence that on average, women pay more than men for the same car model. Okay. In fact, I was curious. See, look right here. Did women always pay more than men? No. In fact, I just made that where you didn't see it. But if we look at this, if you look at the second one here, look at this second one. The woman actually paid $100 less than the man. Hence, that is why your claim is about what is happening on average. And if you don't have that in there, then you're just saying every single time women are paying more than men, okay? So that's why that's important. And that was it. That was the end of the answers. Let's just kind of wanted to glance through. Your third point was achieved if you calculated the correct test statistic and the p-value. All right, and then on the fourth point was achieved if you linked the p-value to the alpha, you did the correct conclusion in context. Okay, so that's how you got your fourth point. Now, again, I wanted to tell you, see, you cannot say, I accept HO, or we cannot say, this is evidence that women pay the same as men. That would be that you fail, you know, or whatever, fail to reject. But you can't ever say those things. Your evidence is always about HA, okay? Your evidence is always, do you have evidence to go to HA, or do you not have evidence to go to HA? All right, that's it. Very good. So now let's take a look at this page 37, I think. So this is a very interesting problem. This was at number 6. This is called an investigative task. These ones they start off with some information that you should know how to do, okay? But then they go into information that is like outside of the box, something that you haven't seen before. Okay, and I think the stuff we're going to do today is the parts we do today are the things that you should be able to do. We've seen before, but then the last thing I'm going to talk about tomorrow is the pages 39 and 40, I believe, and that's the last part of this problem, and that's the thinking outside the box one. I'm not even sure I would have gotten exactly everything they wanted on this one. So, but it's interesting to talk about. I will tell you, as far as the AP test this year, we won't know. I don't know at this point if they're going to have an investigative task, one of these out-of-the-box questions. We're supposed to find out details about that tomorrow. AP will release April 3rd. So hopefully I'll be able to tell you some more information. All right. So this is a problem about people older people, or the people who have this nerve issue, and they have this thing called Morton's neuroma, okay? And it could be causing this, it's the nerve issues in the foot, okay? All right, so that's the premise of what's happening. And we're wondering about the amount of swelling. They're wondering if for a particular person, is the swelling in the dominant foot versus the non-dominant foot significantly? Let's see. I don't know which way right now. I don't know if they say if they think one is more than the other. Maybe we'll find that out in a minute. Okay, so what you need to know is, hey, this right here is one patient. Okay, this right here is another patient. So that's telling me that this is paired data, okay, of course, because you're going to be matching their situations with their feet, okay? And so, and we wonder if that's going to be related to what particular foot they have. All right, so we're wondering, I guess, if the dominant foot has larger swelling. Maybe the acid on the next one. All right, so that's just kind of the premise behind what's happening. Now let's go to the actual questions on this next page. So here this problem is showing, it says, here we have this scatter plot. And in fact, I'm going to let me pull up a blank page of that just real quick. Because, you know, that was kind of a tricky thing, that you ended up having to notice, the goal, you know, was that you noticed that there was that pattern happening. And so if we take a look at this down here, this blank page of this, then let's see what's going on. All right, oh my gosh, my dog will not stop. She keeps making me pet her. Stop. Okay. Okay, thank you. All right. So the idea here on this one that was supposed to happen is that we've got the swelling in the left foot and the swelling in the right foot, okay? So that's how they organize the data, left foot versus the right foot, okay? And just glancing, I'm wondering what's, at this time I'm saying, okay, I wonder what's different about this one down here. Oh, this one, they did dominant foot versus non-dominant foot, okay? So I can tell that they've kind of organized this two different ways, left foot, right foot versus dominant foot, non-dominant foot. And in doing so, I can see a clear pattern here, okay? It looks like, in this case, all of the data is falling in that one clear pattern, okay? Up here, not so much. Okay, I'm not going to lie. If I was to look at this from the get-go, I might have just seen no pattern at all. Okay, I think, though, that, you know, if you actually went and looked at the piece of data, for example, this person with the left foot, anyway, I think that you would end up seeing that this is, when their left foot is low, you know, their right foot had a lot of swelling. And I think we end up seeing that these are the ones that had right foot dominant. Their right was dominant. Okay, because the right foot had the higher amount of swelling. Okay, and then kind of, if we analyzed the data, and then this is kind of another section of people. And you can see the larger values are in the left foot and the smaller values are in the right foot. So in this case, these ended up being the people, you know, we could go and look at it and actually look at the pieces of data, because it's not too much to do that. Those are the ones that are left dominant. Okay, so let's take a look and see then what was happening. And where did my answer key go? Over here. Okay, there we go. Okay, so the question that was asked is, use the scatter plot to suggest there are two distinct groups of patients. Okay, so I guess then they said that's how you knew to kind of look at it. Patients within each group share a common trait. Use the scatter plot above and the table on page 10 to determine what common trait and explain how this trait differs for the groups. Okay, so I think that's what I noticed. I can tell these ones here have a low left foot swelling and a high right foot swelling. Okay, and that's why that ended up being the right dominant ones. And then the other one in blue here is the opposite. Okay, so what I wrote was this. I was very careful in explaining the common trait and explain the difference for the two groups, okay? So my point to you is just be careful in like really looking at what they ask so that you answer exactly what they're asking for. So here's how I did that. I said, the common trait is which foot, left or right, is dominant. Okay? So the right foot dominant was happening here, okay? Because the right foot has more swelling, okay? And then the left foot is dominant here because the left foot has more swelling. So I answered this. What's the common trait? Okay? And explain how this trait differs for the two groups. So the difference is the right foot dominant versus the left foot dominant. Okay? All right. So again, just make sure you are picking apart exactly what they're asking for so that you answer both specific things. Okay, we could look at the grading on that real quick. Let's see how that went. So grading wise, here's what they said. Let's see here. Component 1. Actually, that's not the grading yet. Okay, here's the scoring. All right, scoring. Essentially correct if the response identifies the two groups of people as the left dominant foot people and the right dominant foot people. And students do not need to indicate which group is which. Okay, that's good. All right, and so then that's how that you got credit there. Okay, and so now let's go back to the problem. Problem part B says a scatter plot with the ordered pairs swelling dominant foot versus the non-dominant foot is shown below. So they've changed the way that they organize the data. And so then they said, what conclusions can be drawn from this scatter plot that is not apparent from the scatter plot in part A? Okay. So I would say, just me talking out loud here, that as the dominant foot has higher values, the non-dominant foot has lower values, okay? And at this point, see, then I'm wondering, do they want some type of the relationship that there's a positive, maybe linear relationship, okay? I don't know if I would have automatically gone to seeing if that's what they wanted, okay? But I'm wondering if that's what they're wanting. So I probably would have said, as the dominant foot gets higher, the non-dominant foot is getting higher, but the dominant foot ones are bigger. Let's see what I wrote. Okay, so when I did my actual answer, I said, let's see here. There appears to be, oh, look at that. There appears to be a positive linear relationship between the dominant foot swelling and the non-dominant. Hey, I'm not going to lie. I bet you I did that because it was in the answer key. I'm not so sure that I would have gone to that place right off the bat because I didn't ask what type of association is there. They said, what's apparent and that's not apparent from the other one. This is probably what I would have been more likely to say. As the dominant foot swelling increases, the non-dominant foot swelling increases. And I would have said this, the dominant foot swelling is larger than the non-dominant foot swelling. I probably would have personally said these two items, not necessarily, oh, there's a positive linear relationship between those. Let's go look and see what the grading guidelines required to get that full score on this. So let's see here. Okay, here we go. All right, essentially correct. If the response contains both of these components, you had to say something like positive linear relationship or states that the As the dominant foot swelling goes up, the swelling in the non-dominant foot goes up. Okay? Yay. I probably would have done that there. As the dominant foot swelling goes up, the non-dominant foot swelling goes up. Okay? And that, this one, the swelling in the non-dominant foot is greater than that in the non-dominant. Okay? So that's the trend that I see. All right, so there's that. And I think that that's all I had you do today. And I think that what I'm going to have you do tomorrow is, for tomorrow's lesson, is the next part of this, which, yeah. So for tomorrow, you'll do these two parts, which I think then kind of takes you more through the actual test of running the test and that kind of stuff, okay? Knowing what kind of test and running that test. All right, so let's open that up for questions. Any other questions then over what we went over today? How are we doing? Okay, no other questions? All right, that was easy. So if there's no other questions, then I guess that's it. And I will see you guys tomorrow at, okay, hey, it might be, I have a 1 o'clock meeting, might be a teensy bit late to this. So hang around. I'll try to be here probably closer to 1:45 than 1:30. We'll see. Okay, so be aware that I might be a little late. All right. I will talk to you guys later.